In this video, we'll discuss the problem minimum characters to add for palindrome. Previously, this question has been asked in companies like Facebook and Microsoft. So let's read the problem statement and see how we can solve it. So the question says that we'll be given a string S and the task is to find the minimum number of characters that we need to add at the front of the string to make this string palindrome. And a palindrome string is what? Basically, a palindrome string is a sequence of characters that read the same from the front as well as the back. So basically, if you will think about the string that is madam, so madam reads the same from the left to right direction as well as right to left direction. So if the given string is not palindrome, then you have to see that how many characters you need to add at the front of the string. Only you are allowed to add the characters such that the string can become palindromic. For example, if you will discuss the very first test case here, that is basically given as ABA. So if you see this string ABA, how many ABC, if we discuss this test case, that is ABC here. Now in this particular string, how many characters we need to add at the front to make it palindrome? So you can observe that with respect to this B, we can add one B here, and with respect to this last C, we need to add one C in the beginning also. So you can observe that we need to add two characters at the beginning of the string, right, such that we can make the whole string as palindrome. So we added how many characters? We added two characters for the very first test case. Discussing about the second test case, if you'll observe, so we have got what? We have got double A, then we have got CE, then we have got CA, then after that we have got triple A here. So if you'll observe here, what I think is that this much part is palindromic in nature. Okay, internally you will see that this A matches this A matches this A, C and C and E and E. So basically these two extra A's are there for which you need to compensate. So what you can do here is you can basically say that you need to have one A in the starting somewhere here, and then you need to have one A at the starting somewhere here as well. Okay, so you need two A's in the starting. So you need to add two characters at the front of this given string such that you can make it palindromic. So for both the test cases, we needed to add two characters at the front. Let's discuss the brute as well as the optimal approach. But firstly, we'll try to discuss the brute force approach for the given example. So we'll try to discuss it on the second test case. Basically, we'll try to see that how can it work based on the second test case. Okay, so let's quickly copy the second test case before we move further. So let's copy this. So yeah, now what is the naive approach saying here? If you'll observe here, so basically for the brute force approach, we'll try to check all the prefixes. Now what does this mean? The idea is based on the observation that we need to find longest prefix from the string which is a palindrome. Then the minimum characters that we need to add the front will be the remaining characters. Now what does this mean? If you'll observe the second test case, so the second test case was basically this whole string. This whole string, that is double A, CE, CA, and then triple A. This whole string was the original string that was given to us. Now, if I check, is this whole string a palindrome? Is this whole complete string a palindrome? No, it is not a palindrome. So I'll say that okay, if this complete string is not a palindrome, I'll say that okay, we'll check one less character. So we'll check that if this whole string is not palindrome, then let's check that if we reduce one character from the end, is it palindrome? So we'll say that okay, if this much string a palindrome, we'll check. So if you'll observe that then this string, the string that I've highlighted in the red box, it'll also not be palindromic in nature. Okay, because when you will check it for the palindrome condition, it will not come out as palindrome. Then after that we'll say that okay, we'll reduce this character also, we'll not take this character also, and we'll check for one lesser length, that whether we get a palindromic prefix or not. Prefix is basically when we take the characters from the starting till a particular index. So now we'll check for this much length here. Now is it palindromic? Okay, is this much string that I have highlighted right now, is it palindromic? Yes, it is. So if this much string is palindromic, so this means that my job is done. Now this much string is palindromic, so this is the longest possible prefix which is palindromic in nature. Okay, because if initially what I did was, initially if I took the whole string, it was not palindromic. Okay, so we said that okay, let's not take the last character, let's take this much only. So is it palindromic? It's not. So we'll say that okay, let's remove one more character from the end and let's check the palindromic condition for this much. Is it palindromic? Yes, this much is palindromic. Now if this green box is palindromic, this means that this is the longest prefix which is palindromic for us. So basically we can say that we can compensate for these two characters that are outside. Okay, so we can add one character here, one A here for this particular A, and one more A here for this particular A. So basically, this is how we can easily get our answer. So you can observe here, what we'll try to do is, initially we'll try to check for the complete string whether it is palindromic or not. Okay, and we'll also keep a counter with ourselves. So we'll keep a counter variable with ourselves. Initially it will be 0. Initially we'll check, is the whole string palindromic? No, it's not. So we'll increase the counter by 1, that we are we are excluding one character. So we need backup for one character here, this character. Now we'll check this much. Is it palindromic? No, this string is also not palindromic. So we need to exclude one more character from the ending. Okay, we need to compensate for one more character from the ending. So that's why I will update the counter to 2. And now we'll check for this much prefix, whether it is palindromic or not. So is this much string palindromic? Yes. So this means that since it is palindromic, so it's completely fine. I just need to compensate for the rest of the part, that is the remaining string that was not palindromic, the remaining number of characters that are left. So basically 2 characters are left, you can see. So my count indicates that. So that is why I'll return my counter. That will tell me that how many strings are there. If you'll see, what will the time complexity? So for checking one string whether it is palindromic or not, it will take order of n time. Okay, for checking one string, one particular string, or for checking one string whether it is palindromic or not, it will take order of n time for us. So in the worst case, we have to check for all the n strings, right? So that is why all the n substrings basically. So it will take n square time, because for one substring we'll take order of n time for it to check if it is palindromic or not. So for all the n substrings, it will take n square time, because basically what will happen initially, when you will basically pass this whole string, then you will iterate order of n times to check if it is palindromic or not. It will not be. Okay, then after that you will pass this much substring to check if it is palindromic or not. It is not. Okay, so you can see that you have iterated n times and then n times again, and then after that you will check this much string is palindromic or not. This will take again order of n time. So for one substring you will take order of n time. So for n substrings, in the worst case, you will take n square time. So this approach is going to be very time heavy, because it will take n square time here. Let's see how we are going to code it. So basically you can observe here that firstly what we have done is, we have made a palindrome function here. Okay, now this palindrome function is going to do what? Whatever string you are going to pass, whatever basically substring that you are going to pass, it will check whether it is palindromic or not by checking the corresponding character from the starting and the ending. If they are same, it will keep on moving the characters inside, check if the string is palindrome or not. It is a very basic palindrome check function that we have written. Now what will happen here is, initially you will keep the counter as 0, as I've told you that initially you will not exclude any character, and initially you will try to check for the complete string. So that is why you start your I from the end point. Okay, so let me just paste the test case here so that we can discuss about it further. If you'll see, this was our test case that we had thought about. So if you'll see here, what will happen in this particular test case basically is, right now when I'll start off, so my I will be standing here at the end point, and we'll check initially my I, if my I is greater or equal to 0, and the substring from 0 to I, if it is not palindromic. Initially my counter is what? Like if you'll think about the counter, so right now my counter is basically equal to 0 here. Now if I check this whole string, is it palindromic? No, it's not palindromic. So this means that I need to move my I one step inside, and I need to check further. So now after that, what will happen is, now my I will move one step inside. So now my I is standing here. Now we'll check for this much substring from 0 till I, whether it is palindromic or not. This will also not be palindromic when the code will check. So firstly, if you'll observe, my I was here. This much string was not palindromic. So we are leaving one character. So that is why my count will become 1 here. Then after that, my I moves inside, as I told you. We'll check from 0 to I again. Now this is not palindromic. So my I has to shift inside. So the counter will be updated to 2, because you are having 2 remaining characters at the end now. Now I is inside here. Okay, now when this much substring would be checked, so it will come out as palindromic. So the moment you get palindromic, then you will stop, and whatever is the counter, you will return it, because whatever are the remaining number of characters, you need to compensate for them in the starting. So you need to compensate that many characters only. So whatever is the count, that is going to tell you that how many characters are there remaining at the end, for which you need to write the characters in the beginning. So you need to write for this A and this A. So this approach will take order of n square time. Why? Because for one substring, I'll take order of n time. For one substring, for checking it, I'll take order of n time. So for n substrings, I'll take how much time? I'll take n square time. Space complexity would be order of 1, because are we taking any extra spaces here? Are we declaring any extra data structures? No, we are not. So that is why we will have space complexity as order of 1, because the only extra thing that we have declared is the I variable and the counter variable also. So they will take constant spaces only. Let's discuss the optimal approach also. So the optimal approach will be based on LPS array of the KMP algorithm. We'll discuss about the LPS array in detail. Then we'll see how it will help us in this question. But let's see a little bit of observation here. Okay, so the observation will be that the longest palindromic prefix becomes the longest palindromic suffix in its reverse. Okay, so suppose you have got the original string. What is the original string? The original string is basically AACE, then what? CAAA. Okay, this is what you have as the original string. Now, like if you see what is the region that is palindromic here, if you'll see this much part is basically palindromic. Okay, in the original string, the prefix part, longest palindromic prefix is this much part. Now, if I write the reverse of this string, so what will it be? It will be 4 times A. Okay, then after that C double A. Correct. Now, what will happen here is in this particular string, if you will try to observe, so that same part, like in the reverse of this original string, prefix suffix part will be this suffix part will be palindromic. Basically, if you put a mirror here and you reverse the string, then this suffix part will be called as palindromic. So I'll try to use some intuition regarding this when I'll apply the LPS approach. But how will that help us? We need to observe that, because what will happen here is if you will see here, let's say if I have got a string that is, let's say, ABC. Let's say I've got a string that is basically ABA, and then I have got D. Now, in this particular string, if you'll see how many characters I need to add in the starting to make it palindromic. I need to add only one guy in the starting to make it palindromic. I need to add one guy here to make it palindromic. Now, how can I get this answer? So basically, if I have got this original string that is ABAD, now after that I'll add a hash here. Okay, why I'm adding hash? So that I can basically differentiate between the string and its reverse. Now, when you'll add the reverse, what will be the reverse for it? Reverse will be basically DA and then B and then let's say like you'll have what? You'll have A here. This is what you're going to have now. What will happen here is when we'll run the algorithm for this particular string, okay, so we'll get to know that how many what is the longest common prefix which is also a suffix here. So basically, if you'll see here, what will happen is what will happen here is basically this is a prefix which is also a suffix. Correct, fine. So one length is sure. Then if you check for length too, so like prefix is not a no, like prefix and suffix are not the same. Then after that, if you check the next part, so ABA is there, ABA is there. So like you can see that length, like when my length is basically 3, so for 3 length, prefix is also a suffix. If you check for 4 length, is the prefix same as suffix? So prefix is basically ABAD and suffix is basically DABA. So is the prefix same as suffix? No, it is not. So what is the maximum till which we were getting the same? We were getting the prefix same as suffix till the length 3 when we added the string and its reverse. Because if you see here, like this is the original string, this is the reverse. Now, what is the longest prefix which is also a suffix here? So longest prefix which is also a suffix is of length 3, because ABA is acting as a prefix and ABA is acting as a suffix which is common. If you check for 4 length, then you have ABAD and you have DABA. So they are not the same. Okay, and then hash will ruin everything else. So you can see here that ABA is the same. So till length 3, the prefix is same as suffix here. So that is why what will happen, the LPS, the longest, like the LPS that you'll get, the longest prefix that is also a suffix that you'll get for the string plus its reverse plus hash plus its reverse would be of length 3. This tells us that 3 characters are like same. So in the original string, if you have ABAD, so this means it says that if you get the answer as 3, it basically indicates that in the original string, the first 3 characters, not only behave as a prefix, but this is the longest palindromic prefix that you have. Okay, this will behave as the longest palindromic prefix. Okay, because if in the LPS array, longest prefix which is also a suffix, longest prefix which is also a suffix, if you get the length as 3, then this means that in the original string, this substring of length 3, this prefix or this substring of length 3 is palindromic in nature. Correct. This substring of length 3 will be palindromic in nature. How many extra characters you need to add then? Only one character. So how can you get that? N minus the longest prefix which is also a suffix. So n minus length of the string is how much? 4. 4 minus 3 you will get is what? You will get 1. So you need to add one extra character. So this will be the logic. Basically, if you have read about the KMP algorithm, then the logic for LPS would be very easy. So let's discuss the case here, like how we'll be building up our LPS array, longest prefix which is also a suffix. So let's say if I had a normal string, let's say something like AB and then AB and then I had something like C here. So basically, firstly, what we will do is we'll say that if you have got only substring like A here. So if you have got only substring A, for any substring, we'll always check the proper like prefixes. What does this mean? If you see this whole substring, what are the proper prefixes? Empty string is a proper prefix. A is only AB, ABA, and then what? AB, and then ABC will not be taken. So for a particular string, if you are checking its proper prefixes, you will not check the whole length here. Okay, you will check till one less. The prefixes that the proper prefixes will be one less length. Okay, now what will happen here is when you have got this particular string here with you, so right now if you have got like if you will see LPS of 0, the like LPS of 0 would be what? If you will think about the LPS of 0, so like for a string which is of one length, the proper prefix prefix for it, proper prefix for it would be empty. So like for a string which is of one length, there will be no prefix that is of lesser length than it, because there is an empty string. So that is why the answer for LPS of 0 will be updated to 0 by default. So you'll update what? You'll update 0 here. Then after this, what will happen is what will be LPS of 1 here. Okay, so when you have the string till index 1, like LPS of 1 means string from 0 to 1. Now for this string AB, do you have any prefix which is also a suffix? No, because prefix is A, like prefix you can understand is A, and at suffix you don't have A. So that is why you will update what? LPS of 1 would be updated as 0 as well. Okay, LPS of 1 will be 0 as well. Now after that, you will check for LPS 2. LPS 2 means string till the index 2. So LPS of 2 would be what here? If you'll observe here, so the like if you have got ABA here, suppose you have got ABA. If you have got ABA, so longest prefix which is also a suffix, it is of length 1 basically. Why? Because like if you have like ABA, then A is acting as a prefix as well as a suffix. So the longest prefix which is also a suffix in the string ABA will be basically from here to here. This is string. The longest prefix which is also a suffix is of length 1 only. So LPS of 2 will be updated to what? 1 here. Now after this, what will happen? If you will see next time, so LPS of 3 will be what? So the LPS till the index 3. So LPS of 3 will be basically longest prefix which is also a suffix. So AB is the longest prefix which is also a suffix in this case. So the answer would be what? Answer would be 2 here. Now after this, like what will happen next is you have to generate for LPS of 4 here. When you have to basically generate for LPS of 4 here, what will that be? Now LPS of 4 basically would be nothing but if you will see here, you have got AB, AB, C here. So is there any prefix which is also a suffix? Because A is there, C is there. So you can see that there is no prefix which is also a suffix. So LPS of 4, so LPS of this complete string would be 0, because for this whole string, you don't have any prefix which is also a suffix. So that is why it will be basically 0 here. Let us see the code for the LPS array here. So what will be done here? Firstly, like since we have discussed the code, but let's discuss it once again. We have discussed the dry run properly. What will happen is you will first of all have the length of the pattern string, because the LPS array will be the same size as the pattern string that is given to you. Okay, then after that, what will happen is you will update the length to 0 by default, and you'll start from the index 1, because as I told you, LPS of 0 will be by default 0 only. Now what will happen here is you'll start from the index 1, and while I is less than n, till this point you will iterate until you reach the end of the string. Okay, if the I and the length like pattern at the length index are same, then you'll update the length by 1, and then LPS of I would be updated to length of updated length, and then I plus plus will be done. This is what we have discussed in the dry run as well. If the like ith character and the length and the character at the length index, they are same, update the length, and then LPS of I will be equal to what? Length of the LPS, and then do I plus plus. Otherwise, if they are not same and the LPS is basically, suppose that if they are not same and the LPS is not equal to 0, then in that case LPS of length will be updated to LPS of length minus 1. So basically, if the if at this index the ith character and the character at the length index, if they are not the same, then you will check for one length lesser, so that you can reduce the redundant calculation, okay, by using the pattern here. Otherwise, if the length is basically 0, then you cannot access length minus 1 in the LPS array. So you have to update the LPS of I to 0, and you have to do I plus plus, and at the end of the day we need to return this LPS array. Okay, now how will that help? Because LPS array ultimately helps you to do what in this question? It will help you to find the longest prefix which is also a suffix here. Now how does that help? Because after like you get this string, let's say ABAD. Okay, so in this string you can see that this much part is basically the longest prefix, which is basically palindromic in nature. Now, when I'll do what? When I have this original string till this point, and I'll add a hash or any special character. Suppose assume that I can add a dollar or a hash, any special character I can add here. So I'm adding dollar here for clarity. You can add anything. Let's see what we have added in our code. We can add dollar. You can add hash or dollar, any special character, such that it is not an alphabet here. Okay. Then after that, you can add the reverse of this. So reverse will be what? Like reverse will be DABA. Okay. Now, if you see this whole string, okay, which is containing the original string plus the special character plus the reverse string. Now, in this whole string, tell me what is the length of the when you will iterate through this whole string, when you will check the LPS for this whole string, what is the longest prefix which is also a suffix here? So the longest prefix which is also a suffix here is what? Like the length of the longest prefix which is also a suffix is this ABA. Okay, so when you will check this whole, let me update this like this. Okay, so when you will check the LPS for this whole string, let's assume that you are checking the LPS for this whole string. Assume that this is the last character. So basically, whatever this special string is, when you'll check the LPS for this, finally for this whole string, it'll basically come out as how much? It will come out as 3. When it comes out as 3, so basically it indicates that in the original string, the first three characters, like the first three characters that are there, since the length is coming out as 3, it indicates that first three character is the longest prefix, which is basically palindromic in nature. Okay, so since it is palindromic in nature, that is why you do not need to add for those three characters. So basically, at the end of the day, whatever LPS you get from, like, you will find the LPS of the string plus a special character plus the reverse string. Whatever LPS you get, that LPS, finally whatever LPS you get at the last index, after checking for this whole string, whatever LPS you get at the last index for this combined string, that will basically tell you that how many characters are there in the original string, which are there as a prefix, that are behaving in a palindromic manner, that are basically palindromic in nature. So what prefix is there? What is the longest prefix? That is palindromic in nature. Once you have got this length because of the LPS process, then you'll subtract it from the length of the original string. So the length of the original string, let's say, was 4. Okay, when you'll subtract, so 4 minus the LPS of this whole combined string, which is 3, so you get 1. This indicates that you need to add only one character in the starting. So you'll return this particular value here. So that is why what you will do is you will basically say that at the end of the day, we need to in our code, if you'll see the code here, like I'll talk about the rest of the process as well, but if you will see the code part here, so at the end you need to return n minus the last element of the LPS array, because last element of the LPS array will tell us about the about the final answer for the complete combined string. So let's see one more thing. Let's see a dry run. So let's assume that we have an input that is a string s which is having character s0, s1, s2, s3, s4. Then if you concatenate dollar here, then this is how it would look like after concatenation. Now let's see how different values of the last LPS array would help us to find the largest palindromic prefix here. So if the last element of the LPS array is basically 1, suppose if the last element of the LPS array is 1, if for whole of this is string, okay, if for this whole string, if we get only the LPS length, if the last index of the LPS array indicates that the answer is for it is 1, this indicates that only one last character is the same, and for the rest of the character we need to basically compensate. Okay, so only s0 is palindromic, only one character. But suppose if the last element of the LPS array is basically 2, so if the last element of the LPS array is 2 for the combined string, then that would indicate that the first two characters are basically palindromic in nature, and we need to compensate for the rest of the characters in the original string. Otherwise, if the length comes if the length is basically 3, in such a case, what we need to say is that the first three characters are basically palindromic, and we need to compensate for the last two. So in the brute force code, you can see that we were for every substring we were checking, so we were running order of n loop, but LPS array would do the job in order of n time. That will be the advantage here. Suppose if the last element of the LPS array, it was indicating the length as 4 here, if it was indicating the length as 4, in such a case, it indicates that in the original string, first four characters are palindromic in nature, Okay, and we need to compensate only for the character S4. But if the last element of the LPS array, if it indicates the length, suppose as 5, that is the length of the original string as well, then we do not need to compensate, so the whole string is palindromic, so number of characters required to add would be 0 in such a case. So let's discuss the final code for the approach as well. Okay, I have already told you about the LPS generation concept and the detailed dry run for it. Now, if you will see what will be done, firstly, you take the length in the main code. You have to just take the length of the original string. Then you have to generate a reverse string as well. And after that, you have to update the string with string plus dollar special character plus the reverse. For this particular string, you will try to find the LPS. Okay, basically, you will for this whole string, the LPS at the last index would indicate the longest prefix, which is palindromic in nature for the original string. Once I get the LPS, then basically what I need to do is I need to return n minus the LPS of the last index. That will be my answer, because if you will see, as I had told you already, if I had D as the original string, then you add a dollar here, and then you add the reverse also, so DABA, then the LPS for the last index would come out as what? LPS for the last index, LPS minus 1 in Python language would mean the LPS for this whole string. It will come out as basically 3, because the longest prefix, which is also a suffix, is basically of length 3 here, ABA. Now this means that basically when LPS comes out as 3 for the combined or the joint string, this indicates that the first three characters are showing the palindrome like feature. The first three characters, the substring of length 3 is palindromic, and we need to compensate only for the remaining characters. So remaining character will be how much? The total length of the string minus the last LPS value, that is 3. So 4 minus 3 would be 1 here. So we need to compensate only for this last character here in the case when we take the string ABAD here. Okay, I hope you have understood this clearly. The time complexity taken for my code would be how much? If you'll see the time complexity, so it is going to be nothing but order of n here, because we will take order of n time to generate the LPS array. Okay, that's the only time that we take here. And if you see the space complexity, so it will also be order of n, because we are going to generate an LPS array. So LPS array, we are going to generate a LPS array. LPS array would be same as the size of the given string, so that will be order of n space complexity. I hope you have understood this question so far clearly. Let's now try and submit this code also. So let us try and submit this code to see if it is getting accepted or not. It is the same code as we have discussed. So you can see that the code is getting accepted clearly. I hope you have understood the complete intuition for it. Make sure to comment understood if you have clearly understood. In case if there are any doubts, you can mention in the comments. Thank you for watching this video.